Hey Dr. Ahmed, I'm going to talk to you about shearing stress. But before I talk about that, I should probably talk about what regular stress is. So stress is basically just a force that you put upon an object, whether that's push or pull. And there's two types of stresses. There is normal stress and there is shearing stress. Normal stress is when you apply force that is perpendicular to the object that you have. So let's say for this, I have a deck of playing cards and it's on a horizontal axis. If I were to apply a vertical force to it, then that is considered normal stress. But with shearing stress, that is the force that you apply on an object parallel. So going back to the cards, if I were to apply a horizontal force to it with a horizontal object, then that means that is shearing stress. The question that I have is whether or not the surface affects the shearing stress of an object. So if we were to call over here, this is the experiment that I have. I have the objects that are going to be pulled, the string, and then I have this scale that will determine how much force it takes before the object starts to move.
So the equation for shearing stress is tall equals force over the section area, where the force is going to be the string that I pull that's force, and the section area is the area of the object that is touching the surface.
I'm going to start pulling now. And it takes about 5 pounds for the object to start moving.
So for the controlled variable that didn't have anything change with it, the force was 5 pounds, and the area that I calculated was 7.285 meters squared, which would equal 0.69.
This is the second test with honey instead of a regular table. So let's see. Okay, so it took about 10 pounds for the objects to start moving.
So with honey, the force was 10 pounds, and the area was the same, so 7.285 meters squared, which will give you a force of 1.4 tall. So because of how different the numbers were, we could prove that the surface area does affect the shearing stress.